Thank you for inviting me, Paco, and the organization. I will give you an overview of what we are doing in Barcelona. As Paco mentioned, I'm a professor at the UPC. UPC is a big technical university in Barcelona, one of the top technical universities in Europe. I'm also leading a research group in the Barcelona Supercomputing Center. Barcelona Supercomputing Center is in the same campus. We are about 400 people. 40% of the people are from other countries. It's a very interesting place to do research. We host the MareNostrum. MareNostrum is a big facility. And we also share the Barça Stadium for doing some. It's near our department. If you are interested to visit us, you can also visit the Barcelona team. Who is del Madrid here? Okay. My group we are about 30 people doing cloud computing, big data, high performance computing. I will explain what we are doing in this specific area. It's a merge of all the areas. We say cognitive computing is something that, now everybody talk about that. What really mean for us means what we are doing, supercomputing and merging supercomputing with big data technologies. We have a big background doing work with NoSQL, MapReduce, Hadoop, etc., with our MareNostrum, and combining with analytics, advanced analytics algorithms. Okay. The idea is driving new insight based on this massive data available. That means that we can simplify the idea with these four building blocks. Okay, and in what I will explain today is obviously talk about Spark. We are here for that in our supercomputer, and how we can analyze a big amount of data, in this case, image. Okay, image has their own complexity. The first building block, MareNostrum, okay, is not the fastest supercomputer in the world. It's the most beautiful supercomputer in the world. It's true. It's true. It's inside a chapel. Okay. The name is MareNostrum. MareNostrum is a Roman name for the sea, Mediterranean Sea. The MareNostrum is, as Paco say, 3,200 nodes. Each node has 16 cores, two sockets with 8 cores each one. We have about 2 petabytes of storage, 100 terabytes of main memory, an InfiniBand, an Ethernet connecting everything. That means that we can do interesting experiments with this facility. This facility is for other purpose. Okay, we are using that. We deploy Spark in MareNostrum just to start to analyze the behavior of Spark and the applications there. We create a new module. The name is simple, Spark for MareNostrum. The framework runs an efficient the Spark taking into account the submission, the batch queues in order to submit the jobs and the particularities of MareNostrum. Okay, and the same module gives us the possibility to evaluate different configurations. This is important for us to see what happens when we are changing the storage model. You know, the main HPC facilities are using global parallel file system, and we are comparing with HDFS, different networks. We have InfiniBand and Ethernet, different affinities with the cores, different geometries of the cluster. We can do all these type of things with this model that we create. For instance, we started to test with a simple shuffle of 1 terabyte. We discovered that there is sensitive to the number of workers per node, and also sensitive to the parts that we divide this workload. For instance, we obtain for this number of workers, 512 workers, with 4 workers per node. That means 128 nodes. We can achieve, for 10,000 parts, we can achieve 100 terabytes per hour. Okay, this is one of the examples. We also test all this model with machine learning workloads, for instance, with k-means, naive Bayes. This follows the behavior that we expect. If you want, I can explain more detail later. What we do with this facility and with this Spark that we already have there, and we are happy with the performance of the environment. Okay. One of the things is what we say multimedia big data computing is the part of the group that is working in the crossover of these main aspects, data analytics, with machine learning algorithms, with social networks, and real-time streaming data. And the important thing is the multimodal. By multimodal, we means merge metadata means geoposition, tags from the user, with the information that we have from the social network, comments, likes, the followers. And very interesting for us is the content inside the images, and we analyze that and try to merge all the information. Let me show you with one case study what we are doing. Okay, we use this for different workloads. I don't know if you know Desigual. Desigual is a company based in Barcelona. I'm sure that all of you know that. No? Yeah. The name, is an asymmetric design. This is the name of Desigual. Patchwork design, very, very interesting work. They are interested, obviously, with the customers, okay, to detect new customers. They are doing work in obtaining information from the network, but not from the image in the network. And we are working together to obtain, to complement the information that they have with the information that you can find in the pictures in the social network. For instance, you can see the image of your products. You can see what your or how your customers feel also, but how your customers are. Also the market trend, for instance. Okay? Especially what they are interested in, where we are centering our work, is about the customers. The customers and the potential customers. Okay? This is important for them to discover how are they customers and how can they identify new ones. Okay? In this case, we created 2 data sets. This is a small proof concept. The first data set is a set of photos from Desigual, 30,000 pictures from, not followers, sorry, from people that user tags with hashtag Desigual, hashtag MyDesigual, hashtag La Vida es Chula, life is cool, no? Yeah, life is cool. This is a very cool company, like Barcelona. It's very cool. It's true, Paco? You are invited. Okay, then the other data set is the followers of Desigual now in Instagram is about probably 150,000, more or less, okay? We obtained 100 pictures for only 2,000 followers. And then with this information, I don't want to extend. If you want, I can explain more detail. We try to characterize the followers, okay? And for them, this is very, very important, as you can assume, and you can imagine different things that they can do with this information. the edge. We are using the latent user attribute inference, probably some of you know, okay, basically to predict what can be future. For our project means future followers is enough for them, but you can assume that they have the value for them is do other steps. Okay, we try to obtain information about age, gender, home location, travel patterns, etc. Okay. All these ideas, we are developing a platform. The name is Catwalk. It's a social media image analysis for fashion industry market research. You know, in Barcelona there are more than one company. It's a hub also for fashion. We have relation with other companies, and the multimedia. This is a multimedia big data computing platform. Okay, the proof of concept is done in the MareNostrum. Okay, this is the idea. Let me only talk about small technical issues. I'm not want to go indeed just to some of them. No? For instance, you know that each DFS can handle lots of files. Okay, is designed for streaming access, no, of large files. And here we have a lot of files. Then what we can do is use sequence file. Okay, you know that. For instance, we are building tools to ease the process of help to use the same tools that we are using for other type of data, and then what we are is transforming the image, okay, with vectors, and then we can apply MLlib, for instance, and for I don't know, search for classification, visual similarities, etc. The result is something like this. Okay, we have this package already. Will be someday open source or open to the community, but now, as the previous speaker is not stable, and we need to and also is deployed in the MareNostrum, and now to work there is not open source at the moment. Then the idea is, as you can see, transform a sequence file to RDD is very easy, and vectorize, and then use this information with a typical algorithm, learning algorithm. Okay. We also work. Sorry, I'm locality sensitive hashing. Okay, in order to the idea is to reduce the dimensionality of high-dimensional data. For instance, to obtain information about spam detection, visual spam, or copyright. The idea is to similar image the algorithm put in the same bucket, and then try to identify this. The idea is to include all these in the same tool that I mentioned. Okay, we are doing more things. Okay, we are obviously scaling and distributing. The idea is distribute all these algorithms. The previous one, the visual recognition, the near replicas detection. We are also working with the standardization groups, and the idea is to unify the representation of the metadata. Okay, and we are using an ISO standard from JPEG, and let me cross my fingers, we hope to launch this after summer. It's our idea. Okay, that's all. My idea is I will post the slides after the presentation. I will, if you want, I will tweet it. I have an idea for the organizers. Okay, why not the next summit in Europe, in Barcelona? We have a meetup about Spark. We are now more than 500 people. Okay, The team of Paco already did a presentation because we have the Spark, the Strata conference in, I don't know, 4 months ago. I think is the best place to, and I invite you to visit the MareNostrum. Okay, thank you.
Hi. The Spark Summit Europe, is that finalized? Or is,
No.
or is that being developed?
I have a dream. I have a dream.
Catalonia would be the best place. Absolutely.
Thank you, Paco.
Other questions?
Okay, thank you.
Okay. Thank you, Jordi. Thank you very much.